So now we're going to get into the meat of it. Now that we can identify an expression versus an equation, and we know what makes it linear, now we're going to look at how to solve a linear equation. And we're going to be solving linear equations, and you'll notice that it says in one variable. All of chapter 1 is in one variable. When we get to chapter 2, we're going to go to 2 variables. So that's why they keep stating this. But really, we're just solving linear equations. Now, there's 2 properties that you need to know to be able to solve linear equations in one variable. They are the addition property of quality and the multiplication property of equality. The addition property of quality states that you can add whatever you want to an equation as long as you add it to both sides. So for example, if I was going to add c, as long as I add c to both sides of the equation, I haven't actually changed the equation at all because I've kept it equivalent, right? Addition property of equality. So what we do when we're solving a linear equations is we have our goal of solving for x, so isolating x. So the story that I want to go through your head is what is in the way of getting x by itself? Oh, there's this minus 5. How could I get rid of a minus 5? Well, if I added 5 or did the inverse or opposite operation of minusing 5, then negative 5 plus 5 would give me 0. So I would have x plus 0. Now that would give me just an x by itself. But I'm not allowed to just add 5 to one side because I haven't kept my equation equal. So what I do to one side, I also do to the other. And I would end up with 9 plus 5 is 14. So I end up with x is equal to 14. So this is the addition property of equality. I'm allowed to do whatever I want to one side of the equation or add whatever I want to one side of the equation, as long as I do it to the other side as well. If I was to check this, if I was to plug in 14 for x, 14 minus 5 is 9. Left side is equal to right side. I'm good to go. So what about this one? Okay, I want to get x by itself. What's in the way of getting x by itself? A plus 3. What's the opposite of adding 3? Subtracting 3. What I do to one side, I also do to the other. I do this because now I'm left with x plus 0 on the left-hand side, which I do not need to write, is equal to 5 minus 3, which is 2. To check this solution, I would plug in x is 2, 2 plus 3 is 5, left side equals right side. I'm good. So this addition property of equality worked. Now, I just want to make a little kind of comment of this is called the addition property of equality. I just subtracted 3. Why am I allowed to subtract in an addition property? Well, because when you're taking away 3, you can think of it as adding negative 3. I have this whole rant about how I think BEDMAS is a joke because everybody thinks that you have to do your divisions before your multiplications and then your additions before your subtractions. I'm like, division is multiplication and subtraction is addition. So really, I think BEDMAS should be called BEMA, and I think a lot of students would have way more understanding. So for example, subtracting is adding a negative number, and then division, instead of dividing by 2, you could think of it as, well, I guess I'm about just giving away what I'm going to talk about next, but dividing by 2 is the same as multiplying by a half. So division is multiplication, subtraction is addition. It doesn't matter if they call it the addition property of equality. So I already gave away the punchline for this guy, but this one's called the multiplication property of equality, and it states that you're allowed to multiply whatever you want on one side of the equation as long as you also multiply the other side by it as well. So for example, if I did that same story, I want to solve for x. What's in the way of getting x by itself? Oh, a dividing by 5. What's the opposite of dividing by 5? Multiplying by 5. So if I do 5 times x divided by 5, I could think of this as 5 divided by 5 times x. 5 divided by 5 is 1, so I'd be left with 1x. By doing the opposite operation, oh, what just happened there? Sorry about that, my screen jumped. So by doing the opposite operation of division, which was multiplication, I was multiplying and dividing by the same thing, which makes it just a 1. And then what I do to one side, I also do to the other, and I would get x is equal to 10. If I was to plug this into check, I would get 10 divided by 5 is 2, 2 equals 2, left side is equal to right side. So then same thing here. I want to get x by itself. What's in the way of getting x by itself? A multiplying by 3. How would I get rid of a multiplying by 3? Well, I would divide by 3. 3 divided by 3 is 1. I'd be left with 1x. What I do to one side, I also do to the other. I would end up with 1x is equal to 12 divided by 3 is 4. If I check the solution, I would have 3 times 4 is 12. Left side is equal to right side. Now, how can we say that this is the multiplication property when we actually just divided? Because dividing by 3 is the same as multiplying by a third. So they can just call it the multiplication property of equality and multiply by a fraction and actually do division. So maybe none of that made sense to you, right? Maybe it made everything make sense to you. I'm not sure. But all we're going to do now is we're going to solve linear equations in one variable, and we're going to use these two properties, the addition property of equality and the multiplication property of equality. So let's go. All right, I have 4 steps here on how to solve a linear equation in one variable. Step 1 is that you always want to simplify first. This can involve clearing fractions or decimals. Now this is in italics because we're not going to do this for a little bit. So for right now, it can involve clearing any parentheses and combining like terms. This is how we simplify a linear expression. Then you're going to isolate the term that has the variable in it using the addition property of equality. And then we're going to isolate the variable itself by using the multiplication property. And then you're going to check to make sure that your answer is correct. If it comes out not correct, restart from the beginning or find your mistake. So I've done one full question for you, and I want to talk about this process of annotating. Can you look at someone's work and determine what they've done? And not only what they've done, but why they've done it. So for example, how did I get from this line to this line? What have I done? Well, I've probably done step 1. I've probably simplified. What did I simplify? Well, I did 4x minus 2x is 2x, and I did 4 plus 3 is 7. So I collected like terms, or I combined like terms. Like terms. So what did I do? I combined like terms. Why did I do it? Because I was simplifying the expression. What about from this line to this line? Can you see what's been done? Well, the -5 is still there. The 7's still there. But now the 6x has become a 4x. Why? Well, maybe I minus 2x and I minus 2x. Why did I do that? Because I was isolating the variable term. I use the addition property of equality to get the x's on one side of the equation. So what did I do? I isolated the variable term. On the right. Now I chose the right because it's backwards to what everybody else would do. And I chose it so that my x coefficient, so the value in front of x, would be positive. So I isolated the variable term on the right by minusing 2x from each side. From each side. Now, this is step 1. This was step 2. To get the x's on one side, that was isolating the variable term on the right. But there's another part of step 2, which is what I did from this line to this line. Now, I minus the 7 from each side so that I could get the x term by itself, and then the numbers or constants on the other side. So the goal of step 2 is to get the variable terms on one side of the equation and the constants on the other. It doesn't matter which side. I tend to pick the side that will give me a positive coefficient on x, but you can pick whatever you want. So I isolated the variable term on the right for this one, and for this one, I isolated the constants on the left. On the left. Sorry, I'm not the neatest with this thing. Okay, so step 2 was all about isolating the variable term, getting the numbers on one side and the constant terms on the other. So I minus 2x to get the x's on the right, and then I minus 7 to get my numbers on the left. Now what? Well, now I'm on to step number 3, which is that I want to isolate x. To get x by itself, I have to get rid of the 4. What's the 4 doing? Well, it's multiplying with the x, so I'm going to rip them apart by dividing by 4. 4 divided by 4 is 1x. And what I do to one side, I'm also going to do to the other. So the next thing I did was isolate. Now I can stop saying the variable. I should just say isolate x by dividing by 4. Now I don't need this part here because I showed it over there. I noticed that I wrote minus 2x from each side. This one I wrote by dividing by 4. This one I didn't write minusing 7 because I can see that I did it here. And then step number 4 isn't really a visible one, potentially, right? It's to check. Now we're going to check this equation solution below. So I'm going to do it down here. Okay, but that was my process. Step 1, step 2, step 3, step 4. Step 1, I simplified. Step 2, I put my variable terms on one side and my constants on the other. And I did this by adding and subtracting. And then I got the x by itself by doing a division or a multiplication by a quarter. So those are my 3 steps. And then the 4th step is to check your solution. If you're going to check your solution, always into the original. So I have 4x minus 2x minus 5. Does that equal 4 plus 6x plus 3 when x is negative 3? So 4 times negative 3 minus 2 times negative 3 minus 5. Draw a line. Does that equal 4 plus 6 times negative 3 plus 3? And the reason we always check into the original is because my mistake might have been in the first step. Maybe I collected like terms wrong. So again, we're going to use a calculator. So I'm going to plug in 4 times negative 3 minus 2 times negative 3 minus 5. And that gives me negative 11. So my left-hand side of my equation is negative 11. On the right, I have 4 plus 6 times negative 3 plus 3, which is also going to give me negative 11. Yay, I solved it correctly. I can declare that my solution is negative 3. Right? Awesome. So now what we're going to do is just a bunch of practice where the questions are going to get progressively harder. So we're going to have those 4 steps, well, really 3 steps in mind every time we do a question. So question number 1, do I need to simplify? Nope. Everything is collected as like terms. There's no parentheses, so I can skip that step. Step number 2, I want to isolate my variable term. When you're doing this, right, I'm going to change this to BEMA. You're going to do addition, subtractions, and then multiplication, division. So the first thing we're going to do is get rid of this 7, this minus 7. I want to get the x by itself. So I'm going to add 7 to each side. I end up with 4x is equal to 24. Then I'm going to move on to step 3, which is to rip the x and the 4 apart. What are the 4 and the x doing? Well, they're multiplying. So I'm going to divide by 4 to get rid of it. And I would end up with x is equal to 6. And then I could just check it quickly. 4 times 6 is 24. 24 minus 7 is 17. I'm good. Okay. There is this little italics thing that I kept on here because when you're doing your questions in your textbook, it's going to say this as well. It says, if applicable, tell whether the equation is an identity or contradiction. None of these will it be applicable to tell whether your equation is an identity or contradiction. All of these are going to get solutions, so we're going to be good. But I just wanted to throw this in there so I don't forget to mention it. Just ignore it until we do the next lesson. Okay. I do one, you do one. So try this one. All right. So hopefully when I say try this, make sure you pause the video. I always try to count to 3 to give you time to pause the video. But for this one, I'm going to minus 5. I'm going to minus 5. I end up with x divided by 3 is equal to negative 1. Then I'm going to get rid of this 3. This 3 is dividing. So I'm going to multiply both sides by 3. And I end up with 1x, and we don't write the 1, but we can, is equal to negative 1 times 3, which is negative 3. And again, you could check it. Negative 3 divided by 3 is negative 1. Negative 1 plus 5 is 4. I'm good to go. All right, let's step it up one more level. In these next questions, have I included a step 1? Do I need to simplify? Do I need to collect like terms? Do I need to expand any parentheses? Nope. So I'm on to step number 2, which is to isolate my variable term. I want to get my x's on one side and my numbers on the other. I'm going to do this using the addition property of equality. So it doesn't matter whether you move the x's first or the numbers first. I tend to move my x's. So when I look at this, I have 2x on the left and 7x on the right. I like to give myself positive coefficients, so I'm going to minus the 2x. What I do to one side, I also do to the other. I'm left with negative 9 is equal to 7x minus 2x is 5x minus 12. Then I'm still on step 2 because I need to get my numbers on the other side. So I'm going to add 12 so that I could take it to the other side. What I do to one side, I also do to the other. And I'm left with 3 is equal to 5x. And then lastly, I want to get x by itself. So I'm going to do my multiplication property of equality. So I'm going to divide by 5 or multiply by a fifth. So that 5 divided by 5 is 1x. And what I do to one side, I also do to the other. And I get an answer of 3/5. Now, if you were to check this one, if you plug this into your equation, it would be 2 times 3 divided by 5 minus 9, right? So you just type it in as you see it. 2 times 3 divided by 5 minus 9, and you get an answer. The other question I get a lot is, could I just put this as 0.6? And the answer is sure, right? So if I actually do 3 divided by 6, I'm having this moment of panic that that's not 3 divided by 5. Perfect, is 0.6. So when you get this nice decimal, like a 0.6, you're allowed to put that as an answer. But if you get an answer like 1 divided by 3 or a third, and it's 0.3 repeating, you can't really write that answer without rounding, unless you want to use the repeated sign. So I have a habit of just answering as fractions, but decimals, when they're nice decimals like that, are absolutely fine as well. So either of those would be an acceptable answer. Okay, I do, you do. Try the next one. So for this one, I'm going to put my x's on the left. So I'm going to add 2x to each side. I end up with 7x minus 11 is equal to 3. Then I'm going to add 11 to each side. I end up with 7x is equal to 14. And then lastly, I'm going to get x by itself by dividing by 7. This should end up very robotic. Okay, this process is something you're going to be doing throughout the entire course. Most equations, even quadratic and rational and radical, end up as a linear equation that at some point you need to solve. All right, so that one was a step up because we had x's on both sides versus the beginning question. Right? So if you look at this one, I chose these ones because they didn't have x's on both sides. I chose these ones because they did have x's on both sides. And now these last two sets of questions I chose because you have to simplify first. So if we look at this one on the left, the first thing I'm going to do is look on the right-hand side and see that I could collect like terms. I would end up with 5x plus 11 is equal to negative x minus 13. Then I'm going to move on to step 2. I'm going to put my x's on one side and my numbers on the other. When I look at this one, I've got a negative x, so I'm going to add x to each side so that I end up with 6x. I have 6x plus 11 is equal to negative 13. So I get the 6x by itself, I'm going to minus the 11. You end up with 6x is equal to negative 24. And then lastly, to get x by itself, I'm going to divide both sides by 6, and I end up with x is equal to negative 4. I do, you do. So pause the video, give this one a go. I'm going to collect like terms. I end up with 2x minus 3 is equal to 4x plus 13. I will mention if you put 13 plus 4x, it doesn't matter. It's totally fine. You can do whatever you want. Then I would have a tendency to put my x's on the right, but don't feel like you have to. So I don't know if you've already tried this question or not, but let's just do it the other way around. What if I minus 4x? What if I really love my x terms on the left? What if I don't want to look at whether the coefficient is going to be positive or negative? It's totally fine. I would end up with negative 2x minus 3 is equal to 13. Then I would add 13 to each side. Sorry, not 13, 3. And I would end up with negative 2x is equal to 16. And then I would divide by negative 2. So if you don't make the coefficient on x positive, it just means you're dividing by a negative, and that's totally fine. 16 divided by -2 is -8. So even if I had put things on the other side, I would still get -8 as an answer. Okay, there's lots of ways to peel a potato in math. Um, yeah, I just try to show you that it's okay to have your x's on the right, but it's also okay to just always have your x's on the left. It'll work out. All right, 2 more questions. Last 2 questions, I just put in some parentheses. So for this one, we're going to distribute first. Always take whatever the sign out front is with it when you distribute. So this is going to be x, and then plus 3 times 3x is plus 9x, and then plus 3 times -1 is -3. On the right-hand side, I'm going to distribute a positive 4. So I've got 4x plus 8 plus 4. Then I'm going to collect like terms. I end up with 10x minus 3 is equal to 4x plus 12. Then I'm going to isolate my x's on one side and my numbers on the other. So I'm going to minus the 4x from each side. That's going to leave me with 6x minus 3 is equal to 12. Then I'm going to get the 6x by itself by adding 3 to each side. I end up with 6x is equal to 15. Then I'm going to divide each side by 6. Now, I get the answer of 15/6. There's one problem with this answer. It's not a problem that it's a fraction. It's a problem that it's a fraction not in lowest terms. So, is there any common factor for 15 and 6? So, for example, 15 is 3 times 5. 6 is 3 times 2. So there's that common factor of 3 that I can take out, and I can write it as 5/2. If you had put it into your calculator and you got 2.5, that's a perfectly acceptable answer as well. If you went to go check this, you could plug in 5/2. You'd plug it in as, let's just do this one. Okay, if you were to plug this one into your calculator, you would plug in 5/2. So 5 divided by 2, or just put in a 2.5. Plus 3 bracket 3 times 5 divided by 2 minus 1 bracket. So I'm putting it in just as I see it. And that gives me 22. Then I'm going to plug in the right-hand side. I get 4 bracket 5 divided by 2 plus 2 unbracket plus 4. And I also get 22. So left side is equal to right side, which means that that is the solution to the equation. You could declare it by putting set brackets around it, but it's not necessary. All right, last question. Give it a go. So I'm going to distribute. I get 12x minus 8 is equal to 38. Now I'm distributing minus 2 through. Minus 2 times 2x is minus 4x, and then minus 2 times -1 is 2. That is a big mistake for people. I will just say, if you've tried this one yourself and that's where your mistake is, you are not alone. Some people actually like to throw in a step where they show the multiplication, like 4 times 3x plus 4 times -2 equals 38 minus 2 times 2x minus 2 times -1, and then they'll simplify. Totally up to you. But people often forget to distribute through the second number, and they also always mess up their signs. Just saying. All right, collect like terms. I've got 12x minus 8 is equal to -4x plus 40. Then I'm going to isolate my x's on one side and my numbers on the other. I'm going to choose the left-hand side for my x's. So I'm going to add 4x to each side. I end up with 16x minus 8 is equal to 40. Then I'm going to add the 8. And I get 16x is equal to 48. And then I'm going to get the x by itself by dividing by 16 because it's the opposite of multiplying. What I do to one side, I also do to the other. And I end up with x is equal to 3. I had to think about that one for a second. All right, so hopefully those started feeling really repetitive. And I do want to encourage you to find your own way. Some people end up, they move the numbers and the letters at the same time to get the x's on one side and the numbers on the other. That's totally fine. Some people don't show this underneath. I will say that Even I'm prone to mistakes. And if I show it, I don't make mistakes. But if I don't show it, I'll sometimes just make a silly integer mistake. So when in doubt, show work. But I also understand when you're doing a bunch of homework, sometimes it's nice to show less. So you do you. If you're ever questioning what you're doing, feel free to come and ask me, and I'd love to help.